Welcome. In this video, we're going to look at one of the problems under the Newton's laws of motion. So the question says, a 10 kg block is placed on a frictionless inclined plane connected to a 5 kg block as shown in the figure below. So this is the figure where we have this mass and this mass being connected by this frictionless incline. In fact, being connected by this string here and being inclined at this theta. So the first question is, what would the angle of inclination be for the block to be motionless? So what angle should this be so that the blocks remain at rest, so that they do not move? Then the second part is, if the angle of inclination is 87 degrees, what would be the acceleration of the blocks? Now, if this angle has this value, what would be the acceleration of the blocks? And the third question is, calculate the tension in the string. So the tension in the string. So now let us try to come up with the free body diagram, of which the diagram has been drawn already here. So here we have this free body diagram, which is so for this mass, for object one or for the mass one, we have the normal force, which is the normal force, and then we have the weight here that points directly downwards. And then from here, we express the component, or rather, what we need to do here is we need to express this in terms of twisted coordinates, where we're going to have this one and the angle that is going to be between the mg and this one, it is this theta, and the same angle, this angle and this angle must be the same. And this one under the twisted coordinates, it is going to be the mg cos theta, and this other one, it is the mg sine theta, and this is the same. So even this one, it is the mg sine theta. This is equal to this, and so this is what we're going to proceed now. This is how we're going to handle this question. So the first question that we have is asking us to find an angle of inclination for the block to be, or for the blocks to be motionless. For the blocks to be motionless. Then before we go to the solutions, we also need to come up with a free body diagram for the second part, which is this, which is mass 2. We call it mass 2. So we have the tension here and the mass. So the tension and the mass. Circumstance such as this one, the summation of forces. The summation of forces must be equal to MA. So from here, the summation of forces in this direction, we have the T, which is going in this direction, and the mg cos sine theta, which is coming in this, or which is going in this direction. So what we're going to have is, we are going to have T minus mg sine theta is equal to, so since this is the M1, this is the mass 1, and this is M1A. So let us call this equation number 1, and this is for mass 1. So this is for mass 1. For mass 1. Now, let us also come up with the equation for mass 2. So here, we assume that the object is coming downwards like this one. So what we're going to have is, we're going to have even there the summation of forces. The summation of forces, and this usually we call it in y direction. This must give us, when it is moving, it is going to be the m2g minus t. The m2g, so we have the weight here, which is m2g. Then minus t, this must give us m2a. So let us call this equation number 2. So one, we have this. So what we need to do is, we just need to add equations 1 and 2. So add equations 1 and 2. So what we're going to do is, so this one we have t minus m1 d sine theta plus, on the left side, m2g minus t. This must give us, on the right, we have 1, m1a plus m2a. So from here, we can see that this and this will cancel, and what we're going to have is the negative m1 g sine theta plus this one. So we can even write it like this, m2g minus m1 g sine theta. This must give us, so here we have the common acceleration, so we can even factor it out, m1 plus M2. So from here, now the first question demands us to find the angle of inclination so that the blocks are motionless. So for question number 1, for the blocks to be motionless, A must be equal to 0. So if we follow this now to say if A is equal to 0, so we are going to have M2G minus M1G sine theta. This must give us A times this, so it will be a 0. As a matter of fact, let us try to call this equation number 3. So from here, what we're going to have is we're going to say M2G. When this crosses the equal sign, it is going to be a positive value, M1G sine theta. And since we want to find theta, which is the angle of inclination, what we're going to do is we are going to divide both sides by M1G, even here M1G. So that this and this will cancel, and G will cancel. And from here, what we're going to have is sine theta will be equal to the M2 over M1. Now, from the data that we have, the M1 or the M2, the M1 was 10 and the M2 was 5 kg. So here we have the M2, which is 5, over 10, which will give us 0.5. And the theta is found by just the sine inverse of 0.5. And when we punch this on a calculator, what we're going to get is 30 degrees. So this is the angle at which the incline should be so that the blocks are motionless. So from here, what we're going to do is now we're going to find the acceleration. We're going to find the acceleration of the blocks. So since the blocks have the common cable, they are connected by the same cable, they are going to have a common acceleration. And from this same equation that we just mentioned to be equation number 3, so we can use this equation. So what we're going to do is we are going to say M2G minus M1G sine theta is equal to A, then M1 plus M2. So what we need to do is we just need to make A the subject of the formula by simply dividing by M1. Okay, M1 plus M1 plus M2. So that this and this will cancel. And what we're going to have here is we are going to have A is equal to M2G minus M1G sine theta over M1 plus M2. Now, the question that we are needed to find is when this angle is the to do is we're just going to plug in the values. So our A will be, so the M2, the G is the same, so we can even factor it out. G then M2 minus M1 sine theta over M1 plus M2. So from here, let's now plug in the values. So we're going to have 9.8. Then we have 5 minus 10 sine 37 degrees over 10 plus 5. So if we punch this on a calculator, what we're going to have is A. So the value of A will be negative 0.665 meters per second squared. So this is the value for the acceleration of the blocks. And finally, so the tension. So for the tension, we just need to make use of one of the equations that we were using or that we derived, and then the rest will be history. So from here, we have tension. Let's say, for example, the equation 1, which was T minus M1G sine theta is equal to M1A. So from here, we can just say T is equal to M1A. When this crosses the equal sign, we're going to have M1G sine theta. So from here, we just need to plug in the values. plug in the values. So here the M1 we have 10, which is 10 kg, times the acceleration, which is negative 0.665, then plus the M1, which is 10 again, times 9.8 sine 37 degrees. So if we punch this on a calculator, what we're going to get is 1.33 newtons. And this is how